Hi students, welcome again to an interesting lesson on elements, compounds and mixtures by Tr.Mercy. An element is a pure substance which cannot be split into simpler substances by chemical means. Now, some examples of elements are oxygen, copper, sulfur, carbon, iron. Yeah, all those are elements. They are pure substances which cannot be split into any simpler substance by any chemical means. Now, where do these elements come from? So, these elements we are talking about are made up of atoms. And this now brings us to the definition of an atom. What is an atom? An atom is defined as the smallest particle of an element which can take part in a chemical change. So our elements are made from a very small particle called atom. When these atoms combine together, then they make an element. And we have seen the definition of an atom, the smallest particle of an element which can take part in a chemical change. Now, atoms join to form small groups of atoms which we call molecules. So this smallest particle we have talked about combines with other particles of the same sort, other atoms, to form a molecule. So what is a molecule then? Now a molecule is defined as the smallest particle of an element or a compound which can exist separately. So a molecule can actually represent an element because it can exist separately. Therefore, it is made up of a group of atoms that join together. Two or more atoms together form a molecule. So with those three definitions, that is the definition of an element, an atom, and a molecule, we can talk about the chemical symbols of some elements. Now, elements are usually represented using a single letter or two letters which are normally derived from their names, either the English name or the Latin name. Now, the first letter of the chemical symbol must always be a capital letter. Now, for those elements with two letters as their chemical symbol, the first letter must always be a capital letter, while the second letter is always a small letter. So, we are talking about symbols here which represent elements. So, we are saying elements can either have one letter representing the chemical symbol or two letters representing the chemical symbol. So, if it is one letter, it must be a capital letter. If it is two letters, the first letter must be a capital letter, while the second letter must be a small letter. Now here we have a table showing some examples of the chemical symbols of some elements, starting with the ones whose chemical symbol is only a single letter. For example, look at the chemical symbol for carbon. It is a capital C. Nitrogen, it's a capital N. Oxygen is capital O. Hydrogen is capital H. Aluminium has two letters, A and L. The A is a capital letter while the L is a small letter. Phosphorus has only one letter as the chemical symbol, which is P. Fluorine is F, capital F. Bromine has two letters, which are BR, as capital B and a small r. Then we have iodine, which is capital I, boron, which is capital B, and manganese, which is two letters M and N. The M is capital and the N is a small letter. Now, in the same table, we have other elements such as magnesium, zinc, calcium, beryllium, lithium, sulfur, silicon, barium, cobalt, chlorine, and helium. And they have their corresponding symbols. For magnesium, for example, is Mg. The symbols are given all the way to the helium, which is He. So that is a table showing some of the elements with their corresponding symbols. Now finally, in some cases, the symbol of the element is derived from the element's Latin name, as shown below. For example, the Latin name for copper is cuprum. Therefore, the chemical symbol derived from the Latin name is Cu. The Latin name for mercury is hydragram, and the chemical symbol for mercury is Hg. The element lead has its Latin name as plumbum, and therefore the chemical symbol derived from that Latin name is Pb. We have gold in Latin, it is called aurum, and the chemical symbol for gold is Au. We have silver, the Latin name is argentum, and the chemical symbol is Ag. We have sodium called natrium with a chemical symbol of Na. Potassium, kalium. Chemical symbol is K. Iron, ferrum. Chemical symbol is Fe. And finally, we have tin, whose Latin name is tannum, and the chemical symbol is Sn. So that is a table containing the elements whose chemical symbols have been derived from their Latin names. But remember, the first rule applies for all of them. If the element has one letter, even if it's from the Latin name, it has to be a capital letter. If there are two letters, then the first one has to be a capital letter, while the second should be a small letter. So that rule has also been taken care of in that table. From there, we move on to compounds. So we are done with elements. Now we are in compounds. What are compounds? Students, compounds are substances made up of two or more elements chemically combined together. We talked about compounds did we talk about compounds in mixtures? Yes, some mixtures are compounds. If we did not mention compounds there, then let's mention it here in details, that when we have two or more elements chemically combined together, then we are forming a compound. Now, a very good example of a compound is sodium chloride. Now, sodium chloride is part of the salt we use at home as a food additive. So, it's a combination of sodium and chlorine. That is an example of a compound. Looking at common salt, you cannot tell this is the sodium or this is the chlorine. No, they are chemically combined together to form sodium chloride. Though I should not have used that example because the common salt we use at home has some other additions like iodine, like magnesium chloride, and so on and so forth. But let's take pure sodium chloride. It's a compound of sodium and chlorine. Now, another example is water. The water we drink is a chemical compound of oxygen and hydrogen. When you look at water, you cannot tell what is oxygen and what is hydrogen. Why? Because they are combined together chemically. Therefore, water is another example of a compound. Then we have iron 2 sulfide, which is a compound made up of iron and sulfur. When you react iron and sulfur and you heat them together, then they combine to form a black substance, which is iron 2 sulfide, and in that situation you cannot be able to separate them. They have already combined together chemically to form a compound which is iron 2 sulfide. Now let's move on to mixtures. They are made up of 2 or more substances. These substances can either be a mixture of 2 elements, 2 or more elements together. For example, if you take iron filings and sulfur and sodium chloride and mix them together, then that is a mixture. It can be made up of 2 or more compounds. So a compound would be like sodium chloride. You mix it with another compound like lead 2 iodide, for example. Then you will have formed a mixture. Then it can also be made up of combining an element and a compound. For example, iron filings and sodium chloride. That is an element and a compound. So all those situations will give you a mixture. Now the substances combined in mixtures are not chemically combined or bonded together, and they can be separated by physical means. For example, a mixture of air. Air has so many components in it. For example, it has oxygen, nitrogen, carbon dioxide, we have dust particles, we have water vapor, and so on and so forth. Now, we can be able to remove some of the components of air by physical means. For example, if it is dust particles, we can be able to sieve. We can sieve them and we can be able to filter. So filtering can remove the dust particles. We can be able to remove the water vapor by precipitation. We can be able to separate the main components, that is nitrogen, oxygen, and argon, by fractional distillation of liquefied air. All these are physical means. Then we also have another mixture as the mixture of water and sodium chloride. That is a good mixture which we learned earlier on how to separate it. Whereby if you want to obtain both the water and the sodium chloride, then you perform simple distillation. But if you want to only remain with the sodium chloride, then you can perform the process of evaporation. All these processes are physical processes. They are physical means. Naming compounds. How do we name compounds? Now, the naming of compounds is determined by the number and composition of elements which are making up the compound. Remember earlier on we said compounds are made up of 2 or more elements which are chemically combined. Now, when elements combine chemically, they do not combine one atom with one atom all the time. One atom of one element and another one atom of another element, like that. No, it varies because of different condition and situations. Therefore, you need to be able to know how many atoms of this element combined with how many atoms of the other element to form this particular compound. Now, the following will enable us to be able to name the compounds correctly. And in order for that to happen, we have some rules that apply when naming compounds. Let us look at some of these rules. Now, rule number 1. Compounds made of only 2 elements, their names end with IDE. Now, let's look at an example of such compounds which contain only two elements. Now, we have a compound by the name sodium oxide. You see the name ends with IDE. So, it has only two elements present, which are sodium and oxygen. From the word oxide, we get the element oxygen. Then we have sodium chloride, whereby the elements present in sodium chloride are sodium and chlorine only. Sodium fluoride contains sodium and fluorine. Sodium nitride contains sodium and nitrogen. We have magnesium sulfide, which contains magnesium and sulfur. Copper 2 oxide, which contains copper and oxygen. And then you can fill the table for the remaining compounds, which are calcium bromide, calcium nitride, aluminium chloride, silicon 4 oxide, potassium hydride, yes, and so on and so forth. So, see whether you can be able to fill the table with the correct elements present in the remaining compounds. Therefore, we have said this rule is that as long as the name of the compound ends with IDE, then that compound contains only two elements. There is an exception to this rule, which is in hydroxides. In hydroxides, though the name ends with IDE, they contain three elements, and one of them is hydrogen. So hydroxides are an exception to the first rule. It ends with IDE, the name, but it contains three elements. Now the compounds, some examples are magnesium hydroxide. Now this one will contain three elements, which are magnesium, hydrogen, and oxygen. Sodium hydroxide will contain three elements, which are sodium, hydrogen, and oxygen. Copper 2 hydroxide will contain copper, hydrogen, and oxygen. Then can you fill the table for the remaining 5 compounds which end with IDE, but they are hydroxides? Compounds whose names end with ATE or ITE are made of 3 elements, with oxygen being the third element. But those that end with ATE have more oxygen content than those that end with ITE. So note, there are elements that will end with ATE and ITE. Both of them contain oxygen, but the oxygen depends on the name. If it is ATE, that one has more oxygen than the one with ITE. Now look at this table of compounds that end with ATE. For example, we have magnesium carbonate. The elements present in magnesium carbonate are magnesium, carbon, and oxygen. We have sodium sulfate. The elements that are present there are sodium, sulfur, and oxygen. We have sodium sulfite, should be sodium sulfite. The elements are sodium, sulfur, and oxygen again. Copper 2 sulfate is copper, sulfur, and oxygen. Calcium chlorate is calcium, chlorine, and oxygen. Now we have a table of compounds that end with ITE, whereby we have sodium chloride, which has the elements sodium, chlorine, and oxygen. Potassium nitrite, which has sodium, chlorine, and oxygen. Potassium nitrite, which has potassium, nitrogen, and oxygen. We have another element, compound here called sodium nitrite. which has sodium. It's sodium sulfide, which has sodium, sulfur, and oxygen. We have calcium perchlorate, which contains calcium, chlorine, and oxygen. And finally, we have sodium phosphate, which contains sodium, phosphorus, and oxygen. Exceptions to these are hydrogen carbonates, hydrogen sulfates, hydrogen sulfides, and hydrogen phosphates, which contain 4 elements, hydrogen being one of them. So there is an exception here about those elements whose names end with ATE. So when they are hydrogen something like hydrogen carbonate, sulfate, sulfide, phosphate, then it means they have 4 elements and not 3, as we had said earlier. So this is an exception. Look at this table here. The compounds magnesium hydrogen carbonate contains elements magnesium, hydrogen, carbon, and oxygen. Sodium hydrogen sulfate should contain sodium, hydrogen, sulfur, and oxygen. So using the same structure, you can be able to answer the remaining 3 compounds. Answer the remaining 3 gaps about the elements present in the given compounds. Let's now move on to simple word equations. So the moment you hear of equations, I'm sure it takes you back to mathematics, whereby we have addition equations. Now, equation means there is an equal sign. Therefore, we still have equations in chemistry, and when chemical reactions take place, we can represent them in form of a word equation. For example, when you mix iron and sulfur and you heat them together, we said the 2 elements combine to form a compound which is iron 2 sulfide. We can summarize this in a word equation as follows. Look at this word equation: iron plus sulfur, then an arrow going to iron 2 sulfide. That is an example of a word equation. The plus sign at the reactant side in chemistry represents react with. It means react with. So plus means react with. While on the side of the products, a plus sign will mean and. It will mean and. The arrow means to form the product shown. For example, a word equation like hydrogen plus oxygen, the plus on that reactant side means react with. Then the arrow shows equal to. Okay, the product is water. This means that hydrogen reacts with oxygen to form water. That marks the end of our lesson. Thank you so much for your cooperation. I hope to meet you again soon in another very interesting lesson. Attached are some KCSE questions which were from this chapter which we have just completed. Please look at them, attempt them, and you can even write your answers on the comment section so that I can have a look at them and respond. Thank you so much. Be blessed. Bye.